Welcome. Today we're looking into electronic configuration. From the topic, you can see that today's topic is all about um, electrons. Yeah. So today we're discussing the arrangement of electron in the orbitals of an atom. Yeah, of an atom. Before I proceed, let me remind you of something. Yeah. If I have an element X, let's use here 13, 27. I want us to remember what we call number of proton. Also, number of electron. Atomic number. Mass number. If I have an element X, I want all these things. I want you to know all these things, especially this one. Yeah. Before I can proceed to do the configuration. So tell me, what do you think is the number of proton? Number of proton is the number down here, the one down. Yeah, and that is 13. Number of electron is also the one down here. Yeah. Yes, with a condition, provided the element is in the neutral state. Yeah, there is no charge. When we have a charge here, whether positive or negative, the number of electron will now change. Provided you don't see any charge here, number of proton is also number of electron. Yeah. So, atomic number. Let's talk about atomic number. Atomic number is also the number of proton. So, atomic number here is also 13. Yeah. Everything looks like 13. Yeah. How about the mass number? The mass number is the one up here. Yeah. The one up here. Yes. And that is also that is 27. Yeah. One more thing I would like you to remember is number of neutrons. That's neutron number. In this element X, my neutron number is simple. In fact, neutron number, people think is hard. It's not actually hard. Neutron number is simply the mass number minus the proton number. Yeah, we can say up minus down. Up minus down. And that is 27 minus 13. So for element X, number of neutron is 14. Yeah. So if I change this thing now and give you another element, let's say element Y. If I put here now let me say 11, 23. Can you give me all these things for this? I know you can. Sam, I know you can. Now, what will it be for proton number 11? What will it be for electron number? The same thing, 11, provided the element is neutral. How about the mass number? The one on top, 23. Neutral number, yeah, up minus down. 23 minus 11, and that's 12. It's simple, but I want your focus now to be on the electron. What if here now I put here 3 plus? 3 plus means it has lost 3 electrons. Plus means it is losing electron. It has lost 3 electrons. So if you see a charged element is either it's losing or it's gaining. When you have positive, let me say 2 plus. This one means it has lost 2 electrons. When you say 2 minus, it means it has gained 2 electrons. If you have 12 electrons and you gain 2, it becomes 14. Like here now, previously it has 13. Now that it is now charged, it has lost 3 electrons. So with this, I can go here now and change my number of electrons to move from 13 towards 10. Yeah. How about this one? Like this. What does it mean? It means that here, plus means plus 1. The 1 is invisible, yes. So plus means it has lost 1 electron. Yeah. So in this case, the number of electron E is no longer 11. Here is now 10. Yeah. Yeah, that's it. If you see, the electron number here was 13, but when you lost 3 electrons, it became 10. Here was 11. Different elements. How do I know they are different? Different atomic numbers. But you can see, when they lost electron, they became the same number of what? Electron. Y is now 10, S is now 10. Yeah. This phenomenon is called isoelectronic. When different elements with different atomic number are having the same number of electrons, they are called isoelectronic. We'll discuss these things in the app. For now, let's head back to our configuration and see how it works. Yeah. Configuration uses some principle to work, about some rules. Yeah. And these rules, you must know them to be able to configure electrons. The main one, the first one, is the Hofbau's principle. Quickly, let's discuss the Hofbau's principle. So quickly, let's look into the Hofbau's principle. It's simple. This principle is saying that electrons are distributed from the lower energy level to the higher energy level. Yeah. Now you have to understand what we mean by energy level. First, let me show you something called orbital designation. Yeah. When we learn quantum numbers, when we post the video on quantum numbers, you have more wider view, perception of what I'm saying. Look at this. You know, the azimuthal quantum number depends on the value of L. Yes, your azimuthal depends on the value of your principal quantum number. Yeah, whatever here is, here will take its value. If N is 3, then L can be 0, 1, 2. Yeah, L is n minus 1. That will be a topic for another day. So we use these two things as our designation. Yeah, with this, I will go ahead and show you the Hoover's principle, how we put down our energy level. Yeah. Now, before I proceed, if I have N as 4, what can be L? L will be 0, 1, 2, 3. Yes. Permit me to tell you that the subshell for this quantum number is SPDF. Yeah. The SPDF describes the orientation in space. When we do quantum numbers, you have more knowledge on this. This is actually the magnetic quantum number that tells us this orientation in space. Alright, so look at this. This principle is telling us how we can distribute electrons. And it's saying that electrons are distributed from the lower energy level to the higher energy level. Yeah, lower first. Now, how do we actually obtain these energy levels? I will show you. I will show you a method of getting it. What do we do? So what you do, write 1 once, write 2 twice, write 3 thrice, write 4 times. Who's saying twice? 4 times. Write 5 4 times. Write 6 4 times. Write 7 4 times. We are dealing with SPDF. Yes, SPDF is the scope of this course. We don't exceed SPD and F. So with this, when we are done doing this, we'll go ahead and label it. The first column, they all take X. Talking about SPDF. Take note. So second column takes P. I'm showing you a method of getting the energy level. First column S, second P, third D. Lastly, F. Yeah. Try this on your own. Try it on your own. The next thing we'll now do is we go ahead and draw an arrow. Yeah. Draw an arrow. Yeah. Are you see what I'm doing? Yeah. Yeah. In this pattern, the arrows are parallel to each other. So the next arrow will connect 3D, 4P, 5X. The next arrow will touch 4D, 5P, 6X. Next arrow, when you are doing your own arrow, you will see how they will align. You don't go and draw like this. It's wrong. You draw to touch the available orbitals. So with this, we can draw this one this way. Alright. So with this, we can now see our energy level. It's now clear. So how do we achieve this? You look from the tail of the arrow to the head. From the tail to the head, the way it's pointing, and write your energy level. I can write first 1s. Next, from tail to the head, 2s. Tail to head, 2p. Tail to head, after 2p is what? 3s. Next, 3p. Next, 4s. I hope you're with me. Yeah, Sam, I feel you. Sam, tell us, what will be the next? After 3p is 4s. After 4s is what? 3d. Correct. Sam, you're doing well. 3d, we have 4p. We have 5x. We have 4d. Yeah, the next we have 5p and thereabout. We don't have much time for this video, but I know you get the point now. So on your own, draw this thing, draw an arrow, list the energy level without the video. Do it on your own and come back and check. You can pause the video and check it out. So with this, we now know the energy level. So it goes like this, in this direction. At times in your exam, they can give you some random or better designation to arrange in order of increasing energy level. For instance, now I can give you 4p, 3s, 3d, and 1s. 1, 2, 3, 4. Therefore, a number will say arrange them in order of increasing energy level. Can you? Yes. What do? You write out this thing first. You now go ahead and trace them. You go ahead and trace them. So, which one comes first? Is it 4p? Check. I think 1s comes first. You arrange 1s coming first. Next, what comes next? After 1s here is 3x. Yes, 3s comes next. What next? 4p and 3d. What comes first? 4p. 3d comes first. 3d. Then 4p. Yeah. You now write. with an arrow like this and say increasing energy level. With theory, you say increasing, you describe your arrow, increasing energy level. So it's simple. So quickly, let's go get into configuration proper. Yeah. So we know that this is the energy level. It goes this way. Yes. So now, the next thing we look into is our configuration proper. We are dealing with SPDF as the available subshell. So, I want to remind you that S takes maximum of 2 electrons. P takes 6 maximum. D takes 10. F 14. Just by adding 4 to them. 2 plus 4, 6 plus 4 plus 4 plus 4, like that. Yeah. Now, having known this, we can go ahead and configure. How do you configure? To configure, you need one knowledge, which is the number of electrons. Yeah, in an atom. So let's say I want to configure aluminium. Aluminium has 13 as atomic number. I told you earlier, atomic number is also the proton number and also the number of what? Electron. So we shall go ahead and configure using this energy level given to us by Hoover's principle. So this will be 1s. S takes 2. Next is 2s. S takes 2. Next, P. Not just P, see it here, 2P. And P takes 6. Yeah. So far, we have used 4, 10. If you add these things, you will see that we have used 10 electrons. So we have 3 left. So, what's the next thing? 3x. 3x. S takes 2. Yes. After 3x, the next thing is what? 3p. 3p. P takes 6. But how many do we have left? Is it up to 6 left? Let's check. 4, 10, 12. We have one more left. We have used 12 already. One more left. So P will not take 1. With this, we have configured aluminium. Let's configure calcium. Calcium is 20 as the number of what? Electron. Yes, calcium is the 20th element. So we have here 1s2, 2s2, 2p, 6. We have used 10. 3s2. We have used 12. 3p, P is what? 6. We have used 18. 4x, 2. Yes, 18 plus 2 is 20. That's it. Configuration for calcium. Let's do one more. This time, we will take it slowly. Let's do magnesium. Magnesium is atomic number 12. Let's try it out. That will be 1s. 1x. S takes 2. Write these things. Write them in this manner, in this order, the increasing order. Based on Hoover's principle. Write them in this order. I'll write my 1s, 2x, 2p. It's good that as you're writing, you'll be filling the number of electrons. So here we have S takes 2, P takes 6. As you're writing, be counting how many electrons we have shared already. So far is 10. So after 2p, 6, I'll have 3x2. And this is 12. Yeah. Now, quickly, let's do for sodium. In fact, do it yourself. Do for sodium. Sodium is number 11. When you're done, the final answer, to show you're correct, you have 3. You have 3. Is it 3? No. 1, 2, 4, 10. Yeah, you have 3s1 as the final answer. Yeah, for sodium. Now, configuration is very simple. Yeah, and once you know it, you have learned the basics of chemistry. Yeah. Now, once you know this arrangement, you can configure correctly your first 20 elements. Although from 21 to 30, that is your traditional elements. You have some we have where this does not work. Just about two elements, which is chromium and copper. This principle does not work for these two elements because of stability. In the next part of this video, in the next part, we shall discuss that. Also, when we look into configuration of ionic elements, charged elements, we discuss that. Just take note that this principle here has some limitations. Yeah, and that happened on just I think chromium and copper. Also, for the second element, yes, it happened here. I think also in silver and gold. Yeah, when we get there in our next video, we'll talk about it. So for now, configuration is simple. And once you have known this, it means that you can tell the valency, the group and period of any element you can configure. Yeah, for instance, magnesium ended with 3s2. Once your element ends with S, it tells you your group and period. This 3 here tells you your period. The principal quantum number attached to your azimuthal tells you your period, while this exponent here tells you the group, provided it ended with X. Yeah. Now, if you ask with P, what happens? Yes, this one here tells you the period. But the group is not 1. The group is when you add this one here, we add these 2, you get the period. Sorry, the period is 3, the group is 2 plus 1, and that is 3. Group 3, period 3. That's for aluminium. In our next class, we'll look into ionic configurations and limitations of Urbach's principle, and I'll go ahead to show you the Honshu and explain further on polarized exclusion principle. Thank you for watching.